Hello, I'm Jarso Dulacha, the TIAS student at ITS. This is to present data, information, and the content management second group assignment. Our group is the TIAS group, or the International Student Group. As now, the title of the assignment is designing data lake and ingesting or taking the data from the source, from multiple source to the data lake, and making that data suitable for the data warehouse, and then later storing it to the data warehouse. So designing and implementing data lake as well as data warehouses, just the main point which we will discuss within the reports. And the participants are as visible here: me, Jarso Dulacha, Jafet, Negono Gesairo, Samuel, Mbuna, Kimani, and Ogeto Teresa. Those are the participants of this project. When I directly proceed with the point, as I have already said, the main point or the target which you are going to implement within the project is downloading the data set from provided link. The link is already provided for each group on the instructions of the assignment. Then we have already downloaded the data set from that link, and then stored it in the local computer storage. Then the next step is ingesting that downloaded dataset to the data lake. Ingesting. Just before ingesting, there is explorations and the cleaning for identifying the missing value to correct the errors. We have just explored. To explore, we have used the Python files, as we have already just the screenshots of the files are there. We have used the Python program to clean, to check the missing value. We have used the Python. So we have explored, we have identified the missing value, and then loaded the data from source to the data lake first. And then that data which is taken from source to data lake is the raw data. As data lake can support any kinds of data, either it is structured, semi-structured, or unstructured. Data lake can support, can store all kinds of data in its native form. So first we have loaded. This action is not manual action. That is done by the program. We have loaded from source to the data lake. Then within the data lake, there is ingestion steps. Ingestion means taking from the source to the data lake. Then processing layer, making it just processing, rearranging, since the data is raw, processing or making it more meaningful. And then transformation steps is there. We have done those steps. Now this is the program is there as visible here. This program is now program for ingesting data from source to the data lake. Then after we run this program, just this screen display, this is the output of the program to ingest the data into the data lake. As visible here, data summary is there, missing value, look here, missing value is there, missing value 0. So we have explored, we have identified the missing value, and then load the data to the data lake. Then within data lake, we have processed it and then transformed it. This transformation means actually, by the way, data lake and the data warehouses are different repository. When I say they are different, data lake can support any kinds of data in its native form, but data warehouses can support only structured data. That's why we have transformed it into predefined schema. Predefined schema. This just actions may later maybe explained more by another group member. There is ETL or extract, transform, load point there. With it, that is in the data warehouse. But before coming to that, I'm now presenting the data lake. So what we have done in this data lake is that first, we have downloaded data from the provided link within our computers. Then we have ingested the downloaded data. We have explored it. We identified the missing value. We cleaned it. And then processed it and transformed it into the form which is suitable for data lakehouse. Later to store into the data warehouse, first we have to make it in suitable formats. So we have transferred the data, transformed it to more suitable format for data warehouse. Since data warehouses support only structured data. This is just program for ingesting the data. Once the data is ingested, we have to process it, as I have already said. Those are just the main points. And as I've said, there is data transformation process. We have to transform it into the suitable format for the data lakehouse. For the data warehouse, we have to make it the suitable or structured forms. This is the program for data transformation as visible here. The data is first, the data we have downloaded from the link is that it is raw data, which is in the formats of CSV. Then we have ingested that into the source. We have moved or copied from source to the data lake. Then we have processed that raw data and then transformed it. On transformation, it is just first it is the data is in that CSV file is hold this information, the complex information, all information about product, about sales, about location, about time at once. Then we transform it into different interrelated files, different interrelated tables. They are interrelated. They can work or interoperable with each other by their foreign key. So we have transformed it into that form, and then later it is loaded into the data warehouse. That part later will be presented by another group member. And then this is the data lakehouse design, the data lake design. This part is the data sources of data. Then from this source to we have ingested into the data lake. Ingestion means moving the data from source to the data lake. Then that there is storage layer. Storage is for purpose of storing the data. Then that stored data processed. After processed, it is now meaningful. It is accessible for the user. This at the last layer is the layer at which user can interact with it for reporting, for different insights. They can access, they can work with the data. This one is the serving layer, means like just API, the layer at which users interact with the data. This is for processing. This is a storage layer. This is data lakehouse design. As general, I presented the data lake. Then the next presenter can continue.
For the second section, it's the design and implementation of data warehouse. So a data warehouse is basically a centralized respiratory database designed for storing and analyzing large volumes of structured data. It actually integrates data from multiple sources, organizing them into specific or structured schemas that enable efficient querying, processing, and reporting. It's actually used majorly by the data analysts for the business intelligence needs. So integrating data from a data lake house to build a data warehouse involves extracting raw and processed data from the data lake, thereby transforming it into a structured format suitable for data analysis purposes, and loading it into the data warehouse. So in order to build a data house, the raw data is first acquired from the data lake. Then it's cleaned and transformed, enriched by applying business logic, filtering, and aggregating. So in our project, we have 4-dimension tables, which are the product, customer, time, and location, which are encompassed under the fact tables, the sales fact tables, which is one of our fact tables in this project among the 3 that will be listed later. So the dimension tables store descriptive data, and fact tables capture transactional or numerical data. Once the data is transformed, it is organized in a way that supports efficient and effective querying and analysis. And it's loaded into the data warehouse, making it available for reporting and business intelligence tasks. The process ensures that the data is consistent, reliable, and optimized for analysis. So this report actually outlines the data warehouse design, defining the different or the several dimensions encompassed under the different fact tables essential for analytical purposes. So we'll just scroll down. Just above the dimension tables, let me start with the dimension tables. Number 1. Product dimension is our first dimension. So it has got several attributes, which are the product ID, product name, category, subcategory, brand size, color, price, and the supplier. So the second dimension, second page number, is the customer dimension. So the customer dimension holds the demographic and behavioral data of the customers. It is useful for customer segmentation and marketing strategies. So some of the attributes in the customer dimensions are name, gender, age, address. It's all about the details that that identify particular customer. So the third dimension is the time dimension, which has got the date, week, month, quarter, year, and date of the week attributes. The fourth dimension is the location dimension, which has got the attributes of identity, country, state, city, and region. In the fact tables, we had 3 fact tables, but the major table was the sales transaction fact table, which recorded each sales transaction and served as the primary source for revenue and sales performance analysis. In the attributes, it has got the primary key, which is the transaction ID, the foreign key, which is the product ID, customer ID as the second foreign key, time ID as the third foreign key, and location ID as the fourth foreign key, which identify the 4 dimension tables. So the quantity sold, unit price, total revenue, discount, and payment method. So we have 2 additional fact tables, which are the inventory fact tables. So the inventory fact tables captures all the stocks, replenishments, and product movement, aiding inventory optimization and supply chain management. Its attributes are the ID, which is the major key, primary key. Then the foreign keys are the product ID, location ID. And our last fact table is the marketing campaign fact table, which tracks the performance of the marketing campaigns and customer engagement. It supports the evaluation of the campaign effectiveness, and its attributes are the campaign ID, which is majorly the primary key, and the foreign keys are the customer time IDs. So the proposed data warehouse design offers a structured framework for storing, analyzing critical business data. And by leveraging dimension tables such as the product, customer, time, and location, alongside the fact tables like the sales transaction, which help it gain valuable insights into the sales performance, customer behavior, inventory management, and marketing strategy. The design supports data-driven decision-making and fosters business growth. So the second part is the data warehouse schema design. So the schema, the data warehouse schema is designed using a star schema for the first dimension, for the first fact table, which is the sales transaction fact table, to facilitate simplified and high performance queries. The schema consists of fact tables that store measurable transactional data and dimension tables that provide context for facts. The design ensures data is denormalized, thereby resulting in faster query performance and streamlined analytics. The final part is the ERD, the entity relationship diagram, which is illustrated at the center of the schema. We have the sales transaction fact table, which actually splits into the 4 dimension tables and records quantitative data related to sales activities, thereby surrounding the fact table, providing descriptive information. So in the product dimension, in the product dimension, it has got several attributes. For example, the product name, its category, its brand, and the price. The customer dimension has got several attributes, such as the demographics, contact details, and more so. So the third dimension has got several attributes, for example, date, month, and year. The location dimension has got several attributes, such as the country, state, city. So in the entity relationship diagram, so we can see the relationship between each and every entity. For example, the customer entity relates with the location entity by the customer taking the location of the customer. So the taking is the relationship between customer and location. The customer and the product, a customer buys the product, so thereby buying becoming the main relationship between a customer and a product. A product and time, a product is delivered on time, so thereby delivered being the main relationship between a product and time. Time, each and every location picks up a time automatically. So picking becoming the main relationship between the location and time. So in then the final diagram, just scroll a bit. Okay. The third part, I will leave it to Japhet Gesairo.
Okay. Under the extract, transform, and load process documentation, under the extract, this is where we collect data from multiple sources, such as the databases, APIs, and flat files and spreadsheets. And in this phase, it ensures that data is collected in its raw form, preserving its original structure for analysis. At this step, it maintains data integrity. Yeah, there is data integrity and source compatibility checks. They are performed at this stage of data extraction. Then we have the data cleaning. Data cleaning, this is where we do validation. Validations are done in this phase, where data cleaning techniques are applied to address errors and inconsistencies. Validation checks such as domain constraints and range validations are also implemented to ensure data accuracy. Automated scripts and libraries like Pythons, Pandas, and R are often utilized for this phase. Then we have the transformation phase. There's where we do data normalization and aggregation. Normalization, whereby the data is organized into tables to reduce redundancy, while aggregation combines values to derive insights, such as monthly sales totals. Enrichment involves matching datasets by keys or adding computed fields, such as profit profiles, profit margins, or customer lifetime values. Then we have the loading. The loading now, the normalized data into the warehouse. The final phase, this is the final phase, whereby it involves the loading of transformed data into a target system, such as Datawarehouse. Monitoring and logging mechanisms track the performance and error to guarantee seamless operations. And each extract, transform, and load steps plays a crucial role in maintaining data quality and usability. Proper documentation of these processes ensure transparency, repeatability, and this reliability and scalability, and enabling organizations to make data-driven decisions effectively. Let's go up. And this code, the code displayed is a program to load data to the data warehouse used for loading data. And then we have the query analysis for business decisions. Under this query analysis in a data warehouse is the process of examining and optimizing queries to improve decision-making and performance. Businesses rely on data warehouse to store vast amounts of historical and real-time data, enabling them to run complex queries for insights. For instance, in our case, we have done the query for customer segmentation analysis. For instance, the first one we did is a customer location-based sales analysis. Instead of product performance, instead of focusing on product performance, you can analyze customers' behavior based on their location. By querying the location dimension and sales fact tables, businesses can identify regions that generate the highest sales. This is useful for geographical market expansion, targeted regions, promotions, and logical planning. And below is our SQL query that can be used to do the same. And secondly, we have the customer segmentation analysis. After the customer dimension table is loaded into the database, businesses can perform a query to segment customers based on different criteria, such as geographic, spending habits, or customer segments. For instance, querying the customer dimension table to find the average sales amount for each customer segment can help businesses decide on target marketing strategies, discounts, and promotion. These are an example of an SQL query that can be used to do the same, to do the above querying for customer segmentation analysis. And I think I'm done